Okay.
Okay.
Before we start, could you
Yeah.
tell me a little bit about what you would like to achieve, Aline, and
Yeah,
what would
because
be?
I spoke to Robert briefly and I looked at his website, the Swiss Vault, and it looked like a little bit different than the other database companies. So you
Hmm?
can tell me what's different from your database company.
Okay.
Sounds good?
Sounds good. So you can shoot questions, and Bob, you can jump in anytime, of course.
Okay.
First.
Yeah,
Yeah.
Bob is, I assume, one of the you co-founders. So one is the creator of the company, and the other one is, I guess, the technology part of the company.
Oh, I'm a value added, and it's just his technology.
So
Okay.
basically, Bob and I were working on 100-year data storage, and if we can extend it to 1,000 years, even better. But now we're so digital in our society that we need to keep the data for long periods of time. And the advent of AI has shown that it's really the quality and the quantity of data that you have that can help you build a better AI model, right? So they can either help hospitals with patient admittance or patient treatment options, but only if you have high quality data, which we have not been keeping. I mean, I'm sure some things are paper records, but now I think society is going to start shifting a little bit, and it's going to start to either keep everything as a very good record that has high details on it.
Oh,
And so we're trying to figure out how to do well, we got a plan A, we got a product A that's already been available for 100-year data storage. And with Bob has some innovative ideas for 1,000 years long storage that could be really game changing, but it really changes the way we store data at the in microchips or micro components.
1,000 years, that's almost incredible because tapes that taped 30 years ago already going bad, but
Yeah.
1,000 years must be a new metal that you use or a new technology that is gonna make it happen.
Yes, we're dealing with ferroic devices that have relatively long lifespans because they're crystals.
Oh, okay. And I heard in the news about data companies last week, like um, to store AI, Oracle bought almost $1 trillion worth of equipment to store all that AI data they're going to produce. Now there's huge business with AI to store data, and I guess this is a good market for you. You came at the right time. Uh, of
Yeah,
course, they
we
need to.
were starting already. I mean, the genesis was almost 15 years ago when human genome sequencing started to get available to everyone, basically. So what we were doing back then was sequencing the cancer genome samples. And a genome sample is your DNA, right? And you sequence it, and there's 6 billion data bits in there that need to be deciphered. And the result of the data is it's a when you get it, when you try to store it, it's the equivalent of 1,000 DVD movies for one tiny genome sample that you might get from a cancer is like equivalent to 1,000 DVD movies.
Oh,
So if you go to a hospital and you get your cancer genome sequence, and we're working with a hospital in Vancouver, Canada, and that sequences genomes and understands what drives the cancer prognosis, and they have to store a lot of data, and they have to store it for a very long period of time. So we already surmised this was going to be a problem, not only because it's a lot of data, but also because it's your most private data. It tells everything about you, your hair color, eye color, what diseases you're going to get. But the problem with this data, unlike your social media data, whatnot, is because your genome data is shared between all your family members. It's shared with your children and your future descendants. So if your genome data is out there in the public, then an insurance company easily could deny you life insurance because you have a pre-existing mutation or marker. But then it affects everyone in your family as well. Everyone in your family also has the same data. And so they will also be denied life insurance before they're even born yet, if you understand what I mean, Aline. And so it became a pressing need for us to help society preserve kind of democracy and fundamental freedoms by helping them keep this data intact for 100 years, if not longer, basically, because it impacts everyone. You can follow someone's genome family tree by just sequencing them, and you'll know exactly who they are because they have the same genetic traits, right?
If I understand well, your Swiss Vault is for medical application, not for huge data storage.
No, actually, it started as just trying to help hospitals store data. And hospitals, particularly, we learned the problem is that they're usually in the inner city, and they don't have a lot of space. They don't have a lot of electrical power, and they don't have access to a lot of talent pool to run the data centers. Most of the talent pool has been usurped by AWS, Microsoft Azure, or Google Cloud. They've taken all the talent pool out. So you need talented people to be able to run a data center. So we looked studying this problem, and we realized the only way to help hospitals store this data for a long time was to reduce the energy, reduce the space, make it easy to do so, to store the data. So take care of all the automated tasks like data migration, fixing disks, fixing broken files, which some people have to run around and manage that individually. These are automated by our software, but that's what we learned, and that's what we try to implement. But basically what we learned on the same roadmap was that everybody has this problem. Healthcare is not only one, but financial firms, video production firms, government, data records, they all have the same problem with data management. And so it's an applicable universal system, basically.
Oh, that's good. I have thousands of videos. I'll be able to store them on Swiss Vault.
Yes,
Sure.
you will. And of course, the key point is I reiterate what Bhupinder just touched on, is that some data has to be kept confidential, and the only way to do that is to own the machine that you're going to store it in. So if you're challenged for space as to where you're going to put the machine because you've got a small building in a small lot, well, you have to make the footprint smaller. You have to make it fit into a smaller space, because otherwise you're going to crowd yourself out with too much data.
Okay, so what's the solution? To store them at your place?
No, the solution is we're going to sell you an upgrade to your existing equipment that makes the data fit more in less room.
Okay. So the solution is to be able to store it in a small, compact place.
Yes, we're going to compress the data. We've done that already. But how many beta tests do we have running right now? Do you remember offhand?
We have more than 10, basically, and they're not just small ones, they're big ones with the hospital in Canada. And it's a small team, so we have to manage them all pretty much from ourselves, but we're trying to expand by getting funding. We need funding, but we have space data storage, actually very interesting new topic I'll touch on in a second, if you like. But basically, what Bob is mentioning here is that, it's hospitals are one of many sort of customers that can benefit from this. And we are looking at helping a lot of organizations grow with lots of data, but lots of data management on premises. So the key aspect here is we give the technology to you to put it in your office, and you can own the data. Now that's important, Aline, because of the data sovereignty rule. Just only works if you actually own the data. If you put it on somebody else's servers, they can take those servers away and you don't have your data anymore. So controlling your data means basically having it on your premises. And of course, with our technology, you can use it in the cloud. And we're working with Western Digital. Our technology is the only one that can unlock their high density data storage devices.
Mm-hmm.
And so we're working with them to go to market together. And the space companies are what you realize is also a problem, but space and on Earth actually is basically the problem is that you can't continue to build data centers anymore because of the energy crisis that's taking place. And they're using so much energy on Earth and water, which is particularly bad for many communities because there's just not enough water in like Arizona, for instance, and the water is being used for cooling the data centers. So these are creating all kinds of conflicts and problems. And what some companies have decided, there's at least about 6 companies that are going to start to build data centers in space. And in space, you can get infinite amount of power because you can just put the solar panels always facing the sun. So it's 24/7, 365 sunlight. And the space is cold, so you can radiate out the heat all the time. So these are not issues like they're on Earth. You just have to get the data center up in space. But so why they're working with us is because the software that we invented for 100-year data storage works really, really well for this, maintenance of the data integrity and automating all the tasks. I'll stop there. You must have some questions.
Yeah. Would the big players try to take that from you and try to buy it from you? I mean, the people who are selling big data storage for AI companies, what would they do? Would they try to take your technology, or would you in turn try to sell the big companies your technology?
We're trying to work with all kinds of companies, and so hopefully we can generate a partnership.
Yeah.
And we have many more things on our roadmap, so hopefully they'll like to work with us. And so I think once many companies have seen our technology and how we are innovating and disrupting the space, they'll probably try to copy us,
Okay.
and build something similar.
I see. So you and Robert are located in 2 different states? Okay.
That's correct. Yeah, we seem to have lost Robert here, but Robert is in Arizona, and our team in the U.S. is based out of Princeton, New Jersey.
Oh, okay.
And then in Canada, we have a team in Canada. We also have a team in Switzerland, in the German side of Switzerland, in Basel.
Okay.
And so we are also based there. I'm based out of Switzerland for some time.
Okay, so Robert's side is you are one of the creator of that the technology, I guess, or you are one of the founder, and Robert is in charge of getting the word out.
Well, Robert has a great legacy that's really remarkable in developing these sort of crystals that you can put charge on. So they're nanocrystals that if you put a charge on it, they become polarized. So they maintain a polarized state. And with this technology, you can create bits, zeros and ones in the data, so that you can start to record data for at this nano state. And of course, there are other kinds of technologies that are competing with this. But what's so unique about this is that once you write the data with the pulse of, you don't need to put energy back into it again. So it's now very low energy. And we call that non-volatile memory. So you don't have to keep putting energy in to maintain it and also to read it. Then you just have to read it back. But basically, it's also radiation hard. And so radiation hardness means that you always get radiation from the sun that can wipe out, called bit rot, that can wipe out data, especially in space. So you get this bit rot that's happening. So we believe this technology can enable us to now think about 1,000-year storage, because the pulse, so the crystals can retain their memory theoretically for over 100 years.
Oh, but didn't you mention 1,000 years earlier in your interview? But you can duplicate it and make it 100 years more and 100 years more and 100 years more.
Yeah, basically we just have to keep refreshing the data on a chip like that when it degrades. So we have that right now. We have that technology with our software, which also looks at and sees what's changed and it corrects it. But we're doing that on normal disk drives and flash drives. But in the crystal state, we can apply the same technology that it always refreshes those crystals when there's an error that's happened, so that we can maintain it now for thousands of years.
Oh, that's why you have engineers to monitor all these crystals.
Well, no, it's basically it's nanoscale. It's all automated, and it's all you can't even see the crystals, right? So it's all automated and very much digitalized.
Okay, so how can you check in 100 years what's going on? How did you pick the word 100? How did you pick the number of years?
We for us it's we chose a number based on a patient's lifetime.
Oh,
So a
okay,
baby born
okay,
today will live for 100 years. So we
yeah,
said we need to build technology that will enable a hospital to hold that data for 100 years, or any organization to hold for 100 years. So that is where we drew the line in the sand. We said this is 100 years. This is how much data we want to keep data, and I can show you some slides basically about how we do it if you're interested in it. And we basically have to start looking at how to make it simple to store data. And if a disk drive fails, a disk we believe can last for 7 to 10 years easily. And when a disk drive fails, our software writes the data somewhere else.
okay.
So now you have another 10 years, and you write it somewhere else and write another 10 years. So you basically have a mechanism of maintaining that data for continuation as long as the organization needs that data, right?
Got it. So basically, they do a partnership with you and they pay you yearly or every 10 years or something like that?
No, it's a continuous. So we, if you look at Amazon Web Services, they charge you for storing your data. They charge you. Welcome back, Bob.
Yes.
They charge you for Amazon Web Services charges you for storing data and in their cloud. They charge you $23 per terabyte per month.
I see.
$23 per terabyte per month, and we charge $1 per terabyte per month for storage of the data. So it's much cheaper.
So you're also competitive with Oracle and Amazon and all these storage companies?
We hope that they will eventually use our software, but probably not at the near future because they have their own systems.
Mm-hmm. So I'm sure they have also some secret things happening that they don't divulge to people like you. I mean,
Yeah, exactly. Yeah, exactly. And you just mentioned something that Oracle is doing right now that's about AI, and of course they always have many things happening, and we're trying to take one piece of that pie or puzzle and then fix it and make it better.
I see. And you'll be on the market with them, or your name is not recognizable yet? I mean, your brand is not easily recognizable.
Yeah, we just came out of stealth mode about last year, so but we've made some very good progress. The first progress we made is we started working with people who make these high density discs like Western Digital. You might be familiar with Western Digital.
I am.
And Seagate and Toshiba.
Yeah.
And so we started to share our data with them. And then we're going to build joint marketing materials because we help them make their discs work better, much faster.
Oh, that's awesome. So there's a lot of things going on behind the scene that it's not really visible to the public.
So and that part of the industry is not so sexy. People don't look at it going, "Oh my God, data storage, so sexy." No. But there is something about this that's very sexy. That is that we're going into space, and the first thing you need in space is an infrastructure that can help you communicate and collect data. So when what we have done so far has been miraculous. People get that sending us satellite to one of the asteroid belt, for instance, and looking at an asteroid or looking at pictures of different taking pictures of different planets. But that data takes a long time to come back to Earth. But what if you could have it instantaneously? So now you can support activities like, Mars missions or asteroid missions, and that is what people are looking at doing now. And I think that's where our technology will help build a standard for data storage in space or data operations in space. Because Aline, you can't send anybody in space to repair a disk drive, and you can't send anybody to fix a server. You just have to tolerate lots of these failures. And so remember, getting 100-year data storage right is about fixing the data and fixing systems automatically, and but also reducing the data volumes and making the data go faster. And so those things we wrapped up into our technology, and that's why we are being sought after to go into space.
You're sought after by those big companies?
So the ones that are going into space there's actually smaller companies. So they've taken a position to build data centers in space. So they're the ones who are already trying to do different kinds of things. Like I can't name the companies at the moment, but basically they're going into space to put a data center on the moon, or data center around the moon, or data center around Earth, and those are the ones we're kind of working with.
Okay, so
yeah, one of the critical items here is that when we operate in space, we get exposed to all manner of radiation. We happen to have a material that's 1 million times more radiation hard than silicon. That was established a few years back by some people who found it, but then couldn't figure out how to manufacture with it. And
Bob, I told Aline about it already, but I'm glad you're telling the story as well.
Oh, so yeah, so that's something we got together about and decided, we should be a team.
Yes. Oh yeah, because you went off the screen for a couple minutes. But anyway.
Yeah, my phone overheated, oddly enough.
Oh, the phone, you're on the phone.
Yes, I was on the phone and it overheated, and that's a problem. It's not even that warm here in the house, but
don't let that happen to your data centers.
No, I think we can avoid that by with the next generation of materials.
Yeah. So
less energy you use, the less heat you have to dispose of.
Yeah, you gotta have your data centers in very a cool place and ventilated. Like our equipment here, we always have air conditioning. So that's one of the considerations for people who are dealing with big data centers. The two extremes, I guess, I'm not in technology, but I'm sure you have looked into these things. But Robert, as an engineer, you should have foreseen those things from happening to your phone. I don't know from your phone.
I don't know what's going on with this phone either. I bought it from a company called Apple, who are very well thought of, and they're right in your neighborhood. But
it happens.
Every once in a while, the thing just overheats, and I don't know why.
Oh yeah, it does get overheat if the sun shines on it, for sure. Because if I am outside and the sun shines on my iPhone, it shuts itself off.
Yeah, that's kind of where I was. I was getting the giant thermometer of I'm hot on the screen.
Oh, that's what it is. Okay.
Yes.
Okay. All right. But I'm sure that data centers are much much more protected than your iPhone. Anyway.
Well, yeah, they have to be. But
they have to be.
Depends on how well they're designed, but yes, they have to be.
Okay, well, Robert, I understand that your friend here is one of the founder. What is your role in the company since I first outreached to you?
I outreach to other people that I know and try to get them interested in talking about us and thinking about how to use what we've got.
Oh, okay.
So other than that, I'm also writing applications to work on our memory material. That's kind of my focus because that's what I'm bringing to the table.
Yeah.
But yes, it's a huge, hugely interesting area right now, particularly with the rise of AI. We've got all sorts of investment trying to chase AI, and there's a good deal of uncertainty about which AI proposals are going to work best. But from an investing standpoint alone, what we can say is that whoever's technology wins, it's still going to require a lot of data storage. Mm-hmm. And so, yes, the data storage doesn't seem exciting.
Okay, so the word Swiss comes from the fact that it originated with one of the founder in Switzerland. Is that it, or it's just out of the blue kind of word?
No, it was because we were set up in Switzerland and we registered first. We registered a lot and also developed the concept in Switzerland. And the idea to a Swiss vault was because of in Switzerland, it's kind of neutral and has the Swiss vault is also about holding your precious data assets.
Yeah.
Your precious asset is now your data, basically. Your data is your most precious asset. People are willing to buy it, and we create a lot of it, and they're also continuously buying it all the time. But your genome data is also your most precious asset as well. So we're thinking of this data as an asset class or as something that's very valuable. We came up with Swiss Vault as being the direction where we wanted the company to go. You own your asset, and you can maintain it with high privacy and security.
Okay. Well, I wish I was more trained into your technology to ask you more questions, but the overall idea, I understand that it's a technology that would allow you to store very sensitive data and for longer time, and that's all that I need to know at this point. But
you have a few minutes, I can show you a couple of slides and
yeah,
give you
go
some
ahead.
visuals.
Sure, go ahead.
Yeah, okay, sounds good. Let's do that. So this way you can get an understanding why we're different, how we're different. And I'll just walk you through a few slides and we can go from there. So I gotta find where we share. Oh, can I share?
I don't know if I'll be able to see it, but we can try. Maybe you see it on your end and I cannot see it on my end. I'm not sure.
Need to I could send a request, but.
Allow, okay.
Perfect, okay, good. Yep, thank you, I got it. And so I've selected the screen and it should work.
Oh, okay.
The screen share, yes.
Yeah.
Yep. Okay, perfect.
Oh, yeah, that's it. Okay, and for AI infrastructure, reduce energy, CAPEX and OPEX. Okay.
And one of the things to understand was when you send an email with one attachment, let's say you send it to one of your friends or send one, Aline, you send an email to Bob with an attachment.
Yeah.
That one email has the same carbon emissions or carbon emissions output as one small plastic bag, the production of one small plastic bag.
Okay.
So one email is equal to one small plastic bag in terms of how much energy it takes. Because when you send an email, it has to go through a network.
Yeah.
And it has to go to a data center where it has to be processed, CPU, and stored somewhere that Bob can access it from that point. And that all takes all energy. And that energy is equivalent to how much energy it takes to make a small plastic bag. And so you can see then the carbon emissions that data produces globally. Right? It's more than the airline industry. The data uses more energy than Japan uses or Germany uses. So it's a massive, and it's climbing every day. Now with AI, especially with companies wanting to run GPUs that use a lot of energy, they want to bring back nuclear energy, nuclear power plants to run some of these data centers because of the data consumption, the energy consumption.
Okay. Yeah.
So,
Yeah, that makes sense. Yeah.
so we want to make it easy to store data for decades. So we have to heal the data, self-heal the data when data becomes a problem. And then we also have to reduce the energy environmental footprint.
Yeah.
And so we invented a couple of technologies. One is a software, and then another one's a hardware. And I'm going to show you how we work. So the old way to manage data is that this is how it happens. You have a file, so 1 terabyte file,
Yeah.
and you will make a copy of the file
Yeah.
and another copy of the file. Can you see the copies being made? Backup 1, backup 2?
Yeah. Yeah.
Okay. So these two copies is basically 200% overhead just to manage a data file. Remember, our job is to keep the data, and this is how we keep the data is by making copies of it, as in case the servers fail. And so what we said was that you just to have 200% overhead, and 2 copies is creating a lot of energy and materials waste just to have a 1 copy. And the speed is also very limited by this because you can only access 1 copy, not all 3 copies at the same time. So what we did was we invented a system, a software where we can take in data, chop it up into pieces, and spread it across the network of servers. And we make our backup is what's called parity. In blue, you see the blue pieces?
Yeah.
Those are the pieces we call parity pieces. And the parity pieces are mathematical projection. They're not copies of the data. They're just a tiny, tiny mathematical projection of the data. It's a formula that we invented or use from ratio coding, which allows us to recreate the data in case something goes missing. So let's say something happens, you lose a disk, or you lose a node, and you lose 3 nodes at the same time, but your data will always be safe because it will be rebuilt and sent back to the customer at the same time. And so
Oh.
the advantage is in the old way, you have to make 2 copies, you have 200% overhead. In our way, we make that same data, we chop it into pieces, and we make these blue mathematical parity pieces. And so you only have 5% overhead, not 200%. So you have the original 1 terabyte file and a little bit more that allows us to recreate the data. And so this technology has been working. We have it working at a Canadian Cancer Center. The Canadian Cancer Center in the old way had 10 petabytes of raw data and 2 backup copies. So there are 30 petabytes, and they were running out of space in downtown Vancouver. And so with using Vault file system, we chopped up all the data into 8 pieces and made 4 parity pieces, the mathematical projection. And you can see we're down to only 15 petabytes, so half the data volume. So they can now double the data storage capacity without changing anything except the software.
That's awesome. Oh gosh. It's, I
And
mean, even though I'm not buying technology now, I can see the advantage of using your Swiss Vault. Yeah, it's good.
right,
One of the
and
things, one of the things you have to keep in mind about cancer is that there's a huge risk with chemotherapy because a lot of people do not tolerate chemotherapy agents well. For example, in the United States in 2022, we recorded 120,000 fatalities from adverse drug reactions, a lot of which occurred in the cancer treatment space. Now, the way out of the adverse drug reactions is figure out as soon as an adverse reaction is seen, figure out what's different about the patient who got sick from the patient who didn't.
Yeah, exactly. Good point.
And then publish that so that people can be safe.
Yeah, I was doing some of that early research. That's how this started. Was I was doing the cancer genome sequencing and trying to find out the base mutations that were correlated with progressive or treatment of options that were available. But going back to the data management, one of the things that we can do is best now take this technology into space and different places. And Aline, along the way, we had to invent something else. So I'll show you what we invented. So do you see on the left-hand side is this where my arrow is?
Yeah.
This is a typical server rack that goes into the data center. There's basically 48 disks on the front here, where
Yeah,
where
yeah,
the
I see that.
where the red square is.
Yeah.
And then in the back, there's fans and power supply and compute elements in the back. These are very noisy because they're consuming a lot of power, and this 1500 watts heats up very much this whole system. So what we did was we invented a printed circuit board design, and we took the disks and plugged them into there, and we took everything on the back area and put it on the back of the printed circuit board where my arrow is.
Mm-hmm.
So we have the same volume of disks, 48, but we reduced the volume of the system from 57 liters down to 7 liters. So it's an 8-fold reduction in size. So now you can see with this size, you can put it anywhere. It's only 43 centimeters by 15 centimeters by 10 centimeters. So like a loaf of bread, basically.
Wow.
And you can put this in your office. It's quiet. It's only using 120 watts, so 1500 watts versus 120 watts. That means that you can plug it into your office outlet, right? And so you can have a data center in your office. And we can take the small pieces and build them into a large piece. So you can see this Converge rack has the super micro system that you see here.
Yeah.
That's in here. So
Yeah.
there's 12 of them. So there's 2.5 petabytes of data.
Mm-hmm.
And our system can go into this new design. So that gives you 10 petabytes of data. So it's 4 times more data.
Mm.
And the energy is 1/10 the energy for consumption. But the volume of the sizes, this is 2.57 meters cubed. This is 0.74 meters cubed. So one third the size, but 4 times more data. So we're helping hospitals store more data in less space. And then our software takes care of it, all self-managing. So now you see how the two pieces come together.
Yeah.
The hardware reduces the data volumes, reduces the energy, reduces the space, reduces the footprint, and
And
then basically
is it,
our software manages it so that it's always resilient and
and
error-free.
the prices are competitive with the big data centers? I don't know.
Yes, exactly. We're charging with one of our reseller partners. We hope to take it for $5 per terabyte per month, whereas Amazon Web Services is at $23 per terabyte per month. So it's order of magnitude that's 5 times less.
Oh, that's awesome. That's a good point. Yeah. I'm glad you
And then
I'm
yeah,
glad you repeated it. So anybody with a super big amount of data can acquire your data center on your website.
right, correct.
Okay.
And so I mean, we're working with a partner called Kaiser out of Detroit.
Yeah.
And Blade Room out of UK. They build these data centers that are modular. They can be built in 6 months and delivered to any remote hospital or community, or even someone in the city as well. So they can set up their own data center. And these are 30 petabytes, 5 racks, and they consume 100 kilowatts
Nice.
total. But our technology is in there so that we can reduce the energy component and make it self-managing for that company. So that's how we enable it. And here's the little bit more of the actual construction of it. As you can see, this gets delivered into the customer site in 24 weeks or 6 months. We also are going into space. So we're in space. It become very important that now we get into space because the genie's out of the bag. And what I mean by that is anyone who can observe the Earth and calculate in microseconds what's happening on the planet will have a distinct advantage. So what I mean by that is if you take a picture of a cornfield or a picture of an agriculture field, and you can tell what is being planted and how much will the yield be, you can basically undercut the market. You can undercut the market, and you can manipulate the markets, and you can also determine if there's going to be a weather pattern change in microseconds that's going to affect people in downstream. Like we've had cloud bursts happening in Asia and other parts of the world where cities get flooded. It happened in Canada a couple of years ago as well. And if you can observe that from Earth, from space, you can inform them. And now we want to get in space and put, data storage in space and analysis in space so we can do this really quickly. And so with our technology now, we can enable satellites to share the data, distribute it, because we know that satellites will break or they'll fail. And if it fails, you lose your data, but not with our strategy. Now with our strategy, you can keep that data always pristine. If a satellite breaks, you can put up a new satellite and they'll share the data, always maintaining this level of integrity of the data.
Sounds like magic. That's awesome. I mean, it's incredible what the human mind can conceive and then do. I mean, you're a perfect example of that. So it's just a pleasure to talk to you because you have brought to life something that's important. I assume your main, by what you said, your main customers will be first hospitals and then maybe AI companies.
Well, we're finding everybody's trying to find us in the sense who are doing lots of state storage. So we found finance companies that came to us or have installed our software and our hardware. And we have video production companies that in the US who have installed our software and our hardware as well. And we have a data storage data center in Sacramento that's used our software for large data volumes. And they had originally the state of California's data there. So that was a big project. Now we have the Canadian Cancer Center, which will be doing the hardware and software as well. So we were trying to raise money to grow our team, basically. We were trying to make sure that we can scale this so we can bring the benefits around the world. We started to partner with South Africa, where there is a company called Exa Futures, Exa Factory, and they are going to be bringing the technology to the communities there, because when you go to the emerging markets, there's not a lot of infrastructure yet, but they want to play in the data economy as well. They want to be able to participate in the data economy. And the only way they can participate in the data economy is somehow they can manage their own data with sovereignty. And so I think our technology can unlock this. Our roadmap has to be, let's make it less energy, more efficient, easy for everyone to use.
That's awesome. So thank you so much. I enjoyed talking to you because you seem so knowledgeable. So I will. I hope that's what you wanted to present and that I didn't leave anything out. Thank you so much for being on the program, and hopefully we'll speak again.
Thank you very much, Aline. Wish you the best.
Me too.
Of course. Thank you.
Bye.
Thanks, Robert. Bye.
Bye.